Okay, so in number 5, if it asks us to factor, first we're going to look for a GCF, and this one happens to have one. So the biggest number that can evenly divide into all of those is 5, and they also have an x in common. So I'm going to divide each of the terms by 5x. So 15 divided by 5 is 3, and x to the third minus x to the 1 leaves me with 2 x's, so x squared. And negative 10 divided by 5 is negative 2. And I'm left with a single x. And negative 40 divided by 5 leaves me with negative 8. So now I see that I'm still left with a trinomial. So I'm going to continue to factor that further. And it has a leading coefficient, so I need to multiply 3 and the negative 8. So negative 24 goes in the top part of my x. And this middle term of negative 2 will go in the bottom part of my x. So let's make a list of things that multiply to 24 that might add or subtract to give us negative 2. 2 and 12. Let's try 4 and 6. So 4 times 6 gives me 24. One of them has to be negative, and I need it to be a negative 2. So my bigger number needs to be negative. So what I'm going to do is go ahead and write this 5x down as part of my solution, because this, if you took a GCF out, it needs to be brought down to be part of your solution. So now I'm just going to take what's inside of the x, and I have x plus 4 and x minus 6. And then I need to remember if I had a leading coefficient or not, and I did. It was 3, so now I'm going to slide and divide here. And this slides over here, leaving me with 3x plus 4. And negative 6 divided by 3 gives me negative 2. So that is x minus 2. Alright, so number 6 has 2 terms. So first we're going to look for a GCF. This one doesn't have one. But notice that I have 2 terms and that they are both perfect squares. So I have something, I have 2 perfect squares and they are being subtracted from each other. So I have a difference of perfect squares. So I can use the shortcut of taking the square root of each term. So x times x gives me x squared, and 9 times 9 gives me 81, and I'm going to put a plus sign in one and a minus sign in other, and that's all you do for that one. So number 7, we have 2 terms, and there is not a GCF between the 2 of them, but I see that they are perfect squares and they are being subtracted from each other. So I can do my difference of perfect squares shortcut by taking the square root of each term and putting a plus in one of them and a minus in the other. Alright, so if we're asked to factor, we're going to look for a GCF between all 4 terms. This one doesn't have a GCF between all 4 terms, so because we do have 4 terms, we can factor by grouping. So let's group the first 2 terms and the last 2 terms and find separate GCFs from there. So we need to find a GCF just of 6xy and 16x. So I know the biggest number that goes into both of those is 2, and I see that they both have an x in common. So we're going to divide everything by 2x. So 6 divided by 2 is 3. My x's are going to subtract away, and I'm left with a single y. And 16 divided by 2 is 8, and my x's are going to subtract. Alright, so now we're going to find the GCF between negative 15y and negative 40. So I can say that my GCF is going to be negative because they're both negative, and I know the biggest number that goes into evenly is negative 5. So we're going to divide both of those terms by negative 5. So negative 15 divided by negative 5 is 3. Carry down our y. And negative 40 divided by negative 5 is going to be a positive 8. Alright, so you know that we've done something right if these 2 terms match. So we're only going to use one of those in our answer, so we can go ahead and pull one of those out and write one of those. And then my second part of my answer is these 2 GCFs combined. So I have 2x minus 5, and that would be my final answer for that one. Alright, so we have 4 terms, so look for a GCF between all 4 terms. This one doesn't have one. So we can combine or factor by grouping because it has 4 terms. So let's look for a GCF just within this first 2 terms. So it looks like it's going to be, they have a 2 in common, and they also have an x squared in common. So let's divide everything here by 2x squared. So 12 divided by 2 is x. And if I have 3 up here and 2 down here, that leaves me with a single x. And 2x squared divided by 2x squared goes into itself 1 time. So a GCF between 30 and 5 is going to be 5. And 30 divided by 5 is 6. Let's carry down the x. And then negative 5 goes into negative 5 1 time. So notice these two are the same, so I've done something right. So let's pull one of those out as an answer. And we're going to combine these two, 2x squared plus 5, as the other part of my answer.